Okay, and then here's number 2. My copy, I just printed this out. I obviously need new printer ink in my printer, so it didn't come out as nice. I'm going to do this one from scratch all the way through because Teresa asked for that. So I'm going to do whatever Teresa asked for, always. I did this one in class, and on part A, they give us this region. They want us to find the area of region R. So I mentioned that you could do this with respect to X, or you could do it with respect to Y, either way. I'm going to go ahead and do it with respect to X. So I am starting at this 1, right? And we're using the Y equals natural log of X. And this is Y equals 5 minus X. And this is the x-axis, which is really Y equals 0. But if we're going to do it with respect to X, we have to break it up right where the functions change. So that X value where they change is going to be our boundary. So we need to figure that out. What is that spot? So I'm going to do that in just a second. So let me set up what the area is going to look like. Area equals, we need the integral from 1 to whatever that is. So I'm going to leave that blank. And then it's always top minus bottom. So the top is this natural log of X. The bottom is actually just 0. So I don't have to write that. So it's going to be natural log dx plus the integral from whatever this spot is to here, which is 1, 2, 3, 4, 5. And then it's the top minus the bottom, which is 5 minus X minus 0. So we just have to do 5 minus X dx. So to figure out this intersection point, we're going to go to our graphing calculator and turn it on. Y1 equals, I'm going to make that natural log of X. Make sure it's highlighted and turned on. Y2, I'm going to make that 5 minus X. Make sure it's turned on. My window should be from 1 to 5 and hit graph. So we should see this graph, although my Y values they're really big, so I'm going to change my window so we could see it better. I'm going to make my Y max a 2 and hit graph. Oh, and then I'm going to make my Y min smaller so we don't see all this. Let it go. Window. I always forget to change my Y value. So I can just put in 0 because that's the x-axis. There we go. Now we're going to see a better version. Sorry about that. That's the natural log of X. That's Y equals 5 minus X. I need to know that X value right there. So I'm going to hit trace, move closer to it. I'm going to hit second, calculate, and then we need 5. That's going to give us the point of intersection. It should say first curve, enter. Second curve, it automatically jumps to it. I don't know if you can see that. Enter, guess, enter. And then the X value and the Y value are right here. So I'm going to write that down. That's 3.693, 3.693. And the Y value, because people who did this with respect to Y need the Y value instead, 1.307. We're going to round to that third place. So now we know for the X value, this is 3.693 and 3.693 down here. So how do we put that in our graphing calculator? So I'm going to quit out of here and I'm going to go to a clear screen. I'm going to do math 9, 1 to 3.693. Whoops, I screwed up. I'm going to hit clear. Try again. You've got to pay attention to what your cursor is doing so you don't mess up. Math 9, 1, and then use your up arrow so it goes up there. 3.693. Use your arrow button over. Natural log of X dx. So that's this piece. Plus math 9 again. Now it's 3.693 move the arrow up to 5 and over, and 5 minus x and dx, and hit enter. And you should get 2.986 units squared. And that is part A. Okay, let's go down to part B. Part B asks you to do the perpendicular cross section of a square. Write but do not solve an expression involving one or more integrals giving the volume. So this is where we do the perpendicular cross section. So with respect to x, we still have to do those same two boundaries, 1 to 3.693 and 3.693 to 5, because we have to break it up the same way. This is the only volume where you're not rotating it, so you don't need pi. We just need the area of the square, because that's the shape. Area of a square is the side squared dx, side squared dx, and the side being squared from 1 to 3.963 is that distance, again, top minus bottom. Well, natural log of x minus 0 is just natural log of x squared. And then for this piece, it's this distance. So it is 5 minus x minus 0, so we don't have to put the minus 0, squared dx. They don't even make you put that in your calculator. It said to set it up only. So that is the only answer for part B. Part C, you could do different ways. This one is also just a setup question. It's where they give us that there is a line, a line y equals k that breaks this into two areas that are equal. So there's two ways you could set this up. I'm going to do it the way I think of it. So I'm going to take the area, it has to be with respect to y though. There is no way to do this one with respect to x. So we have to integrate from 0 to k, right? And then we have to do the top minus the bottom. But to do top minus bottom, we need to change these equations to y values. I did that in class the other day, so I'm just going to write this one down. This one would be x equals 5 minus y. That would be the top. This one, y equals natural log of x. When we change that to y, it's e to the y. So top minus bottom is going to be 5 minus y minus e to the y, right? And dy. So that has to equal the next part, which would be the integral from k to that top piece, which that y value is 1.307, and it's the same 5 minus y minus e to the y dy. So that shows the two pieces set equal to each other. You can do it that way, or you can do it 0 to k, that just the first part, the first half, and show that that is half of our answer from part A, because part A, remember, is the area of the whole thing. And you can stop right there. So either this one in red or this one in green. And that is FRQ number 2.